Thanks, Hong, for the introduction. So today, myself and my colleagues, Jian and Lijuan Wang, will do a joint presentation on Kinect. We'll tell you what's in Kinect today, and we'll also tell you what's in Kinect tomorrow. So, what is Kinect? Kinect is all about connecting you, the user, and your avatar. And the magic of Kinect is that making this connection without a controller. No controller. Is that possible? Well, now we are going to open the black box and show how the magic happens. The first part of the connection is that Kinect has to recognize you. It has to recognize your identity and facial expression. So today we are going to show you two tracking technologies. One is called Kinect Identity, which can track your identities, and so that the Kinect system can track each user individually. We will also show you Avatar Kinect, which is the technology for tracking your facial expression. Are you nodding and saying yes? Or are you shaking your head and saying no? Kinect knows because it's tracking the orientation of your face. So are you happy? Are you sad? Kinect also knows because it's tracking the movement of your facial features, which means your eyebrows, your eyes, and your nose, and your mouth. The second part of the connection is now that Kinect knows a whole bunch of information about you, then it's going to control the avatar on behalf of you. So the technology for control the facial expression is called facial animation. And today we are going to show you our latest work in facial animation. And then another important technology is control the movement of your lips while you talk. So this technology is called lip synchronization, also called lip sync. So today we are going to show you a demo with a live talking head, and that will be with the correct synthesized lips, talking very naturally. Okay, now I'm going to introduce my colleague Jian to tell you the details about Kinect Identity and Avatar Kinect. While he's setting up, I'm going to say a few things about Jian. And Jian is one of the stories about talent growth at Microsoft. He was our intern, and then he became the employee, and now he's one of the key leaders in the lab. He's a senior researcher. So, Jian, it's your take.
Thanks, Baining. I'm Jian Sun, a researcher from the Visual Computing Group from Microsoft Research Asia. Next, I'm going to talk about the details about the Kinect Identity and the Avatar Kinect. The goal of the Kinect Identity is to recognize and track the identity of the user. Once the Kinect can know who you are, can remember you, our interaction between the computer and the user can be more natural. For example, the user can easily sign on the system using Kinect ID without typing username, without typing the keyword. For another example, since in current Kinect-based game, we don't have the controller, the Kinect Identity can help us to create the connection between the physical player in front of the camera and the virtual player in the game. It can greatly improve the user experience, especially for the multiple player gaming scenario. If the Kinect can know who you are, the computer system can personalize the interaction between the user and the computer. The computer can perform different interaction for different person in the family. So the technology behind the Kinect Identity are a set of a computer vision algorithm. We use face recognition, clothes color, and the body height as signatures for the user recognition. To make the system works well for a variety of different conditions in the living room, we make the face recognition to reverse to different lighting in the living room. We also learn these visual signatures from the real data we collect from the real world. Now, Kinect Identity is running behind many games. So in next video, let's look at the Kinect Identity in the real game.
Hi, I'm usersGÇÖ. I'm a researcher from Microsoft Research Asia. We will introduce how Kinect performs player identity recognition in Xbox, what we call Kinect Identity.
A primary challenge in developing a natural user interface for the Kinect is how to seamlessly recognize a player's identity to ensure a smooth and a natural user experience.
Kinect Identity combines three kinds of information to distinguish the users: face, clothes, and body skeleton.
Using an RGB camera sensor, Kinect uses face detection to find the face area and extract the structural information of the face. For example, the boundary of the eyes, nose, and mouth. Such structural information is then used to distinguish people using image processing and machine learning techniques. People usually wear different clothes, and this is also useful information for recognition. Based on the depth sensor and the Kinect body tracking technique, we can easily separate human bodies from the RGB image and then analyze the color information of their shirt and trousers. Of course, people also have different body shapes. We can compute the relative body height, which is the distance from the user's head to the horizontal plane that is parallel to the ground plane, but passing through the Kinect sensor. Given this relative body height, we are able to distinguish people of different heights. By combining the three types of information, there is a high probability that Kinect Identity will make a correct decision. As a result, the system works quite well in practice, providing a smooth and natural user experience in Xbox 360.
The Kinect can track your body motion. Kinect Identity can track your identity. However, as we know, in our face-to-face communication, being able to see the head motion, being able to see the detailed facial expression are also very important. If we can track your momentary head, your detailed facial expression, we are able to create a virtual avatar for you. We can create an avatar to represent you in the virtual world. So we call it Avatar Kinect. With Avatar Kinect, you can drive an avatar by your body and by the movement of the face. And the avatar will follow your every moment, even your smile. So with this avatar, you can even give a talk using your avatar, as our Steve Ballmer did in CES in this year. You can talk with your friends remotely at any time. You can have a party with your friends at anywhere. The technology behind the Avatar Kinect is a real-time facial expression tracking algorithm. It has two parts, 3D head pose tracking and the 3D facial expression tracking. The first part will figure out the 3D rigid motion of the head as shown on the right. And the second part will figure out the detailed motion on your face. So here is a demonstration video. I will show how our tracking algorithm on my face. And here, the yellow 3D mesh is a tracking result by the algorithm that will follow my head motion and follow the detailed movement of my face. Now, in the next video, I'm going to show how we can use Avatar Kinect in the virtual world.
One, two, three, four.
Ready for the big game?
Bring it on. All right, guys. 5 minutes to kickoff. Let's hear your predictions. Go.
Tigers by 2 touchdowns.
No way, guys. The Ducks are going to run all over you.
In your dreams, the Ducks are going down.
Hey guys, welcome back.
Hey, everybody.
So I loved tonight's episode. What did you guys think?
5 stars. Heather rocks.
Ditto. She's the only reason I watch the show.
Too much drama. 2 stars.
Tough crowd. Facebook fans, what do you think?
Thank you.
Okay, next we are going to bring Lijuan Wang to tell you about facial animation and the lip synchronization, the technologies for controlling your avatar. These are future technologies that will be in Kinect, Avatar Kinect. Lijuan is, while she's coming over here, I'll give a little bit of introduction. She's also our intern and another growth story at the Microsoft Thailand program. Now she's a researcher in the speech technology group. And as you can see, that our talent program only cover both men and women. Okay, Lijuan.
Well, thanks, Baining. Good morning, everyone. I'm Lijuan Wang, a researcher from Speech Group, Microsoft Research Asia. Next, I'll show you our latest technology for controlling an avatar. So now I'll show you our latest facial animation technology for controlling the facial expression of an avatar. In the facial animation world, motion capture and playback is the foundation for high-quality facial animation. Basically, we put a bunch of dots on a lively actor's face and record the motion of these markers. The recorded marker motions is then used to drive an avatar face. The advantage of motion capture is that it provides great motion details of the face. A disadvantage of mocap is that it lacks geometric details because only the motion of the markers are recorded. Laser scan provides great geometric details, but it has no information about motion. Our new technology, called Face Mocap Plus, combines the best of both two worlds. Our new technology provides the motion details of traditional mocap plus the geometric details of laser scan. Here I show you an animation produced by our new technology. Please notice the geometric detail in the animation. Another technology we recently come out is high-quality lip syncing for 3D facial animation. As we know, one challenge for rendering realistic 3D avatar is on the mouth area. Our lips, teeth, and tongue are mixed with non-rigid tissues and sometimes with occlusions, which means accurate geometry modeling is very difficult. And also, it is hard to deform them properly. The lips, teeth, and tongue, they need to move together in sync with spoken audio, otherwise people can observe the asynchrony and think it is unnatural. To solve this problem, we use audiovisual recording of people talking into a camera, so that the voice, mouth movement are simultaneously recorded. Then a statistical hidden mark model is automatically trained to categorize how the mouth moves for each sound. In the rendering, the statistical model will choose the right samples, and then we project the 2D image samples onto the 3D face. This method achieves great realism in high-quality lip syncing and enable a 3D photorealistic talking head that can take any input text and convert it into speech animation. Now I'll give you a more illustrative example of how we combine the 2D image samples with a 3D face model. First, we build a simple head model, and then we synthesize a sequence of images of mouth movement and overlay the image sequence onto a 3D head. You can imagine as the mouth opens and closes in the 2D image sequence, its projection on the 3D face model also opens and closes, and the projection can be viewed from different perspectives. So the result is a 3D photorealistic talking head. Actually, this talking head is built from our colleague, Matt, at MSRA in Beijing, using his 30 minutes 2D video recording. I'll let Matt's talking head do a self-introduction.
Hello everyone, I am Matt Scott, a 3D talking head with lively, lip sync, and photorealistic animations. I am the engaging visualized English teacher on Bing Dictionary. Users can watch my videos to observe how the mouth moves while listening to speech. Through statistical model training, my mouth movement can be accurately predicted from given natural or TTS synthesized speech. Different head motions and facial expressions can be freely controlled and rendered.
Yeah, as you see, the talking head has natural head motion and facial expressions, and it can be easily customized to any user by using his 2D video. It can be seamlessly integrated to any 3D scenes for many potential applications, like telepresence, online gaming, social networking, online shopping, etc. We integrate photorealistic talking head technology into Bing Dictionary as an engaging English teacher. Bing Dictionary is a vertical search of Bing China. It provides online dictionary for English and Chinese. Bing users can watch the synthesized video to learn how the mouse moves with speech in a lip-sync manner for many sample sentences on the Bing dictionary. Now I'll show you an example.
The money stock there did not fall but slowed down to a crawl. The money.
This feature becomes an instant hit in Bing Dictionary among millions of English learners in China. The last demo I'm going to show you is about the talking head language capability. Our latest technology can make a monolingual speaker cross the language barrier and speak in any other language he never learned before. Here shows you the 3D talking head we built for our Chief Research and Strategy Officer, Craig Monday. As far as we know, Craig's native language is English, and he doesn't speak much Chinese. But now his talking head can speak very authentic Mandarin in his voice and with his face. Now the talking head is going to give us greetings for our 20th anniversary in both English and Mandarin. First, in English.
Well, thanks for the introduction, and hello to everyone in Beijing. I am Craig Monday, the Chief Research and Strategy Officer at Microsoft. It's my pleasure to be here with every one of you. I'm highly honored to celebrate this 20th anniversary of MSR together with you. Thank you for all your hard work in the past 20 years, and we are expecting another bright and productive 20 years.
And now in Mandarin, in Chinese.
谢谢，我现在会说中文，这真是太不可思议了。北京的朋友们，大家好，我是克雷格·蒙迪，微软首席研究和战略官。很高兴今天能和大家一起庆祝微软研究院成立20周年。我衷心感谢大家在过去20周年的辛勤工作，我们期待着下一个硕果累累的20年。
Thank you.
Thank you, Lijuan. So before we bring in up another researcher to give a live demo, and then we are going to introduce a video that summarizes the Kinect related work at MSR. And as you can see, many people are behind-the-scenes heroes of this project. Okay.
At the interactive entertainment business, we make science fiction into science fact. The journey we started with Kinect could not have been possible without the amazing partnership with Microsoft Research.
You cannot create a great product, a breakthrough product, by accident. Kinect was a consequence of years of investment by Microsoft.
In a way, Kinect had an infinite amount of miracles that needed to happen for us to bring this product to market. There's 3 technical pillars that have made the simple and intuitive experiences of Kinect possible. And it really is about voice recognition, it's about identity recognition, it's about human tracking. Within each one of those categories, there is a myriad of improbable things that we had to make possible.
We knew that the challenge is enormous. Pretty much, there was no way to over-design the digital signal processing chain, the microphones, the electronics. Everything had to be squeezed to the max to be made to perform the best. We had the technologies at the beginning, but making them work together as a pipeline and to have end-to-end performance was the biggest challenge.
In research, sometimes you work on things that you actually don't know where are the applications. Core technology that we are focusing on is tracking, also your identity. We want a computer to be able to recognize you and continue tracking you. We've developed a software system technology that combines three factors: your face and the clothes that you're wearing and your height to determine whether this is the same player.
To enable immersive gaming, you have to be able to track the body in real time. And moreover, we needed to leave some of the computing resources available to game designers to write their games.
I'd been working on this problem of extracting 3D body position from video when the Xbox team contacted us saying they wanted to solve the problem of human body tracking. We didn't then know what techniques we were going to use to solve it, but one thing I knew from my previous experience was that we were going to need lots and lots of training data, lots and lots of example images that could train the system or even ultimately test the system.
I was involved in the human body tracking part of the system so that it can turn you into an avatar or interpret your body motions as gestures to control the game. This is
really looking at the future of computer-human interaction, away from just the mouse and keyboard into a domain where anyone can interact with computers at any time.
Computers, obviously, thanks to Moore's law, are fabulously powerful now. We're seeing the things that were just unthinkable even 5 years ago are now feasible.
We just scratched the surface.
Microsoft Research's approach to innovation, of doing blue skies research, just because it's difficult, will always lead to great advances in the way that ordinary people interact with computers in the world.
The incredible partnership between the Kinect team and Microsoft Research has allowed us to make tomorrow happen today.
Okay, now I'm